guys, welcome to VChem World. In this lecture, we will discuss on the solubility of gases and solids in liquid. First, start with what is the meaning of the solubility. We know about the solution. Solution is the made up of the two parts, solute and solvent. First, take example. This is the beaker. In the beaker, this is the solution. When solution is made up of the two parts, solvent and solute. How to make solution? For example, consider as the NaCl as a solute and water as a solvent. When particular amount of the solute dissolve in the particular amount of the solvent at a particular temperature, this is known as the solubility. For example, NaCl 10 gram dissolve in 100 gram of solvent at a 25 degree temperature. So this is known as the solubility. When maximum amount of solute dissolve at a particular amount of solvent at a particular temperature, this is known as the solubility. When solute and solvent difference, its solubility different. So we can say that the solubility depends on the nature of solute. Second is the nature of solvent. In definition, we show that we take an example that is the 25 degree temperature. But when temperature is variable, so its solubility is a variable. That way, third factor is the temperature. And fourth factor is pressure. So solubility is variable in the four factor: nature of solute, nature of solvent, temperature and pressure. First, we discuss on the solubility of solids in a liquid, and next we discuss on the solubility of gases in a liquid. The solubility of solids in a liquid, that is the solids in a liquid. So liquid is a larger quantity and solids has a smaller quantity. We know about in the solution two quantity, larger quantity and another has a smaller quantity. When larger quantity, it means that is the solvent, and smaller quantity, that means this is the solute. That way, in the larger quantity is a liquid, so it acts as a solvent, and smaller quantity is solids, so this is the solute. For example, consider as a beaker. In this beaker, this is the large quantity, so this is the solvent. When we add smaller quantity, that is the solute. So we add solute. So this solute goes into the liquid and it's dissolved. When solute dissolve in the solvent, so its concentration increase. Solute concentration increase. So this process, when solute added into the solvent and solute dissolve and increase its concentration, this is known as the dissolution. First term is dissolution. When this solute is a solid, when this solid particle, for example, this is the solid particle, this one solid particle collide with another solid particle and this is the precipitate out, means this converted into its solid. So this is known as the crystallization process. Second is the crystallization. In the dissolution, solute plus solvent, that means solute dissolve in solvent. In the crystallization, solid particle and another solid particle gives the precipitation. So this process is known as the crystallization process. When dissolution process is continuously start, means that the solute dissolve in the solvent. But at the one point when solute not dissolve in the solvent, so that point at a temperature, this is known as the saturated solution. Saturated solution means the no more solute dissolve in solvent. And another term is the when dissolution process start, this is the continuously started, means the solute added into the solvent and solute is a dissolved. But at a particular temperature when we added solute in the solvent, so it's dissolved. Solute dissolved in this the solvent. So this is known as the unsaturated solution. That means the more solute dissolved in solvent. First, we discuss on the dissolution. Dissolution means the solute dissolve in solvent and solute concentration increase. It's known as the dissolution process. Next term is the crystallization. In the crystallization, solid particle collide with another solid particle and precipitate out. So this is known as the crystallization. Next is the when we add more and more solute in the solvent. So that solute is a dissolved. But at a particular temperature or particular given condition, that is the no more solute is dissolved in solvent, it's known as the saturated solution. And at a temperature where more solute dissolved in solvent, this is known as the unsaturated solution. Where the saturated solution means that this is the equilibrium condition. For example, when solute plus solvent, this is the equilibrium with its solution. In the equilibrium of the solution, that means the solute dissolved in solvent. When solute dissolved in solvent, that means this is the dissolution process. And another condition is the in the solid, where another process is the solute in the solid collide with solid. So it gives the precipitation. That means the crystallization process. At equilibrium or saturated condition, this means the dissolution and crystallization is same. That means that when some part of the solute is dissolved and some part of the solute is the separate precipitation. That means the solute, for example, 5% solute dissolved in the solvent and another 5%, that means the solid collide with solids and gives the 5% crystallization. So dissolve and precipitation out rate is the same. That means the equilibrium between the solute, solvent and solution. We discuss on the highest concentration of the solute. First we take example. This is the 3 beaker. In this 3 beaker, 10 gram of NaCl in 100 gram of solution. That is the same, but this is the 20 gram of NaCl and in this beaker 30 gram of NaCl. This is the solvent. When we add 10 gram of NaCl in this 100 gram of solvent, it gives the solution. Means that the dissolution process. Second way same as the when 20 gram of NaCl dissolve in the 100 gram of solution. Where is the 100 gram, 100 gram, 100 gram of the solvent is the same. But also changes the solute. This solute is increased. That means its concentration is more than this. Because of the solute is more amount. Then next term is the 30 gram. When we add this 30 gram of this solvent, so it's make the solution. So its concentration is highest than this 10 gram and 20 gram. But when we add solute for the 31 gram of the solute added into the 100 gram of the solvent, that is not dissolved. Because of at a particular temperature, no more solute dissolve in solvent. It's known as the saturated solution. For example, this is the saturated solution. It means that in the saturated solution, highest concentration of the solute present. Same is the 10 gram of NaCl, this is the unsaturated solution. 20 gram of NaCl, that is the unsaturated solution. 29 gram of NaCl, this is the unsaturated solution. But 30 gram of NaCl, that is the saturated solution. Because of that that is the no more solute dissolved in solvent. That way, maximum amount of solute in this solvent present in this desaturated solution. Discuss on the factor affecting the solubility of solids in a liquid. First factor is the nature of the solute and solvent. We know that every solute are not dissolved in the every solvent. Because of in the solute and solvent intermolecular interaction is different. When solute and solvent intermolecular interaction is same, that means that this solid dissolve in this liquid. For example, consider as the NaCl and water. This NaCl is a polar molecule and this is the polar. What is the meaning of the polar? Polar means the electronegativity difference present. This H2O, oxygen, hydrogen and hydrogen. Oxygen has a negative charge and hydrogen has a positive charge. So in between the oxygen and hydrogen, electronegativity difference present. That means this is the polar molecule. Next, this is the NaCl. So Na plus and Cl minus. This is between the Na plus and Cl minus. This is the electronegativity difference present. This is the polar. That means the NaCl and H2O intermolecular interaction is same. This is the polar. So that way NaCl dissolve into water. NaCl dissolve into water and gives the NaOH and HCl. This is the NaCl and H2O dissolve in water and polar and polar. This is the same. So this known as the like dissolve like. Like means polar dissolve in polar. That same way, consider as the benzene and naphthalene. When naphthalene added to the benzene, we know about the most of the organic compound has a non-polar nature. So this benzene has a non-polar and naphthalene has a non-polar. That means intermolecular interaction between the benzene and naphthalene is the same. So that is the like dissolve like. Like means non-polar, dissolve in non-polar. You remember that the polar dissolve in polar and non-polar dissolve in non-polar. But polar dissolve in not non-polar. For example, consider as the NaCl plus benzene. It means that the NaCl dissolve in benzene. NaCl has a polar and benzene has a non-polar. So NaCl and benzene intermolecular interaction is different. That means the NaCl not dissolve in benzene. Second way, consider as the naphthalene. In the naphthalene dissolve in the water. This is the not dissolve in the water because of the naphthalene has a non-polar and water has a polar. So non-polar not dissolve in polar because of the intermolecular interaction is different. So only remember that the intermolecular interaction is same. When intermolecular interaction same, that means it is a dissolve and this is the different. That means it is a not dissolve. So basic is the like dissolve like. For example, consider as the NaCl in water and sugar. When NaCl dissolve in water, NaCl and water, that is we know about it, that is the polar and polar. So it is easily dissolved. But when sugar dissolve in H2O, that is the easily dissolve NaClH2 because of this is the polar and polar same intermolecular interaction. But in the H2O, this is the polar. In the sugar, that is the covalent. This is a polar, but is the covalent. That means its electronegativity difference is less than the H2O. That means its intermolecular interaction is present, but intermolecular interaction is less than the NaCl and H2O. So its dissolve or its solubility is some amount less than the water. For example, this is the 5.3 solubility. So this is the 3.8 solubility. Because of the covalent nature, and NaCl has a polar nature. That is the like dissolve like nature. Solubility of solutes increase with increase in temperature. That means the solubility increase with temperature increase. For example, consider as the NaCl, Ki, NH4NO3, KNO3. Most of the solute when dissolved in the solvents converted into solution. This process is the dissolution process. In this condition, most of the solute like NaCl, Ki, NH4NO3 and KNO3, this is the solute dissolved in solvent, and this process is the gives the solution. This process is dissolution. But adding factor is the temperature rise. When temperature is rise means that the heat energy increase. Heat energy increase. So this solute absorb this heat energy. That means this is the delta H, and when any factor means that the absorb heat, this is the endothermic, and release heat, this is the exothermic. So in this process, absorb heat, so this is the endothermic process. That means when solute absorb heat, so it's converted into its solution. That means its solubility increase because of the its absorb heat. So this is the solubility of solutes increase with increase in temperature because of the endothermic process. This is the delta H greater than 0. Next is the solubility of solutes decreases with increase in temperature. Some types of salt, lithium sulfate, cerium sulfate and sodium carbonate monohydrate. This type of salt is its solubility is decreased with temperature. Why this is the occur? Because of the we know that the solute plus solvent gives the solution. In this process is the dissolution process. But when affected when increase the temperature, this solute decrease its solubility because of it is the exothermic reaction. In the exothermic reaction means heat release. When solute its heat release and then dissolve into the solvent. That means its solubility is decreased when increase the temperature. That is the delta H less than 0. So we know about that when increased temperature means the absorb heat, that is the endothermic, and increased temperature, and one process is the exothermic means the remove the heat. This known as the exothermic process. In the endothermic process means solubility increase, and exothermic process solubility is decrease. Effect of temperature. It gives the three type of trends. First is the solubility of solids increase with increase in temperature. Second is the solubility of solid decrease with increase in temperature. And third is the solubility shows irregular behavior with increase in temperature. First we know that when solubility of solid increase with increased temperature means that is the endothermic process. Means when temperature increase, solute absorb energy. So this is the endothermic effect. Second is when solubility of solid decrease with increase in temperature, that is the exothermic effect. When exothermic means the release energy. When temperature is given, so solute release its energy and solute plus solvent gives the solution. That means that is the opposite of the temperature. Because of the temperature give the heat and solute release heat. That means that solubility is decreased. And third factor is the solubility shows irregular behavior with increase in temperature. For consider is the example sodium sulfate decahydrate. This type of example, first solubility is increase with temperature. That way, this is the increase with temperature. At a certain point, this is the certain point. Then this certain point, then decrease the solubility with increase in temperature. So this way, this is the decrease the solubility with increase in temperature. So this point, it's known as the transition point. Why this is known as the transition point? Because of the transition means some form to another form. For example, one solid converted into another solid, that's required temperature, it's known as the transition temperature. For example, this Na2SO4 into decahydrate converted into sodium sulfate. So this temperature, where this 32.8 degree temperature, this is the transition temperature. Because of the, in the 32.8 degree temperature, Na2SO4 into 10H2O converted into Na2SO4. And above this temperature 32.8 degree, where is the Na2SO4 converted into Na2SO4 into 10H2O. That way, transition temperature is the equilibrium between the Na2SO4 into 10H2O. Next example consider is the FeSO4 into 6H2O. That transition temperature is 61.8 degree. That means below the 61.8 degree, it is the form as the FeSO4 into 6H2O. Where above this transition temperature, it's converted into FeSO4. So this temperature is known as the transition temperature. That way, in the some example like Na2SO4, FeSO4, CuSO4, that is the solubility shows irregular behavior with increase in temperature. Next is the effect of pressure. What is the effect of the pressure where solid dissolve in the liquid? That means the solubility of solids in a liquid is significant effect of the pressure. Why this is the significant effect of the pressure? Because of the, for example, consider this is the solution. In the solution, this is solvent part is liquid and we add solute. So this solute is solid. When effect of the pressure in this solution, that means in the solution, solute is a solid and solvent is a liquid. But on the pressure effect on the solid and liquid is negligible because of the its incompressible nature. Incompressible nature of the solid and liquid. Why this is the incompressible? Because of the, in the solids, all constituent particles are very close to each other. That means it is strongly attached each other. That way it is incompressible. Same way liquid has incompressible. So that way this is the very minute effect of the pressure on this solids and liquid. For example, consider as the, when given 500 atm pressure to this solution and its solubility increase only 2.3% increase solubility. So this is the minute effect of the pressure in this solid dissolve in the liquid.